So today is October 15th, 2014. The topic is still the same, integers. So since the topic is the same, you can continue your notes that we were taking yesterday about adding integers. Just add to the objective and the essential question. So what you're going to add to the objective is subtracting integers with same and different signs. And what you're going to add to the essential question is how are adding and subtracting integers similar, and how do they differ? Let's go ahead and get started. First, we're going to look at modeling subtraction of integers using a number line. Imagine you're a hiker and you're hiking along the number line. We're going to hike up the number line and we're going to hike down the number line. So here's our little hiker dude over here. Everyone see him? I'm going to start him off on the origin there, which is 0. We're going to hike along the number line using a review problem from yesterday, which is 3 plus -4. So since the first term of the equation is positive, you will face the right side of the number line. So let's go ahead and turn our hiker guy around so he's facing the positive side of our number line. Make sure he's on 0. And then we're going to walk 3 units in that direction that he's facing. So 1, 2, 3. And we land on positive 3. Then add, so that means we're still facing the right direction, a negative, which tells us that we're going to change and turn around and look to the negative direction, which is left. We're on positive 3. And we're going to change directions and look left because it's a negative. And then we're going to walk in that direction 4 units. 1, 2, 3, 4. So 3 plus -4 equals -1. So I'm pretty sure a lot of you are still like, okay, what just happened? So we're going to do a lot of practice problems together. And we're going to look at this using subtraction. So you have to keep in mind the term, the negative and positive signs tell you which direction you're facing, and the numbers tell you how many units you're going to walk. So let's look at a few more practice problems together. Here we have -4 minus 5. You weren't supposed to see that answer yet. So -4 minus 5. Well, we look at our signs to tell us which direction our hiker is going to face. So here's our hiker dude over here. And since we have a negative sign here, we're going to be facing left, which is in the negative direction. So here we go, facing left. And the 4 tells us we're going to walk 4 units in that direction. 1, 2, 3, 4. Here we have another negative sign or subtraction, and that tells us we're going to continue facing left, and we're going to walk 5 units in that direction. 1, 2, 3, 4, 5. So -4 minus 5 equals -9. All right, so here let's try one where we have a double negative. And we call it a double negative because we have a negative here and a negative right behind it. So it's minus, minus, or negative, negative. So it's a double negative. Let's see how that changes our answer. So again, we look for the sign to tell us which direction our little hiker dude is going to face. But there's no sign right here. But still, even though there's not a sign here, this integer would be considered a positive integer because, you know, positives, they don't always have to have the plus sign. There's that imaginary plus sign right there. So that lets you know we are going to be facing the right direction. I didn't like that. Here we go. So here he's on the origin and he's facing the right. Oh, seriously? Here we go. Here he's on the origin and you're facing the right direction. The 2 tells us we're going to walk in that direction 2 units. So 1, 2. This negative sign tells us, oh, we got to change directions. So let's change direction, and we're on positive 2. But then we have another negative sign, and that negative sign tells us, oh, change direction again. And we're going to change direction again. So now we're facing the right, and we're going to walk in that direction 6 units. 1, 2, 3, 4, 5, 6. So we landed on positive 8. So positive 2 minus negative 6 equals positive 8. I already know some of you are like, whoa, what just happened? So let's do a few more questions together. I'm going to try to show you using the colored chips. So let's see if you can get it that way. Here we have negative 4 minus negative 3. Well, negative 4, we're going to start with 4 negative counters to represent the integer negative 4. So here's 1, 2, 3, 4. And then we're going to take away 3 negative counters to represent subtracting negative 3. So I'm just going to black those out like this. So how many counters do we have left? We have 1 negative counter left. So negative 4 minus negative 3 equals negative 1. Here we have 6 minus negative 3. So 6 is a positive integer. So we're going to do 6 positive yellow chips. So here's 1, 2, 3, 4, 5, 6. And then the problem tells us to subtract negative 3. But all we have are 6 positive chips. So in order to be able to subtract negative 3 chips, we need to add 3 zero pairs. So I'm going to add 1 zero pair. And remember, a zero pair is when you have a positive and a negative, the same. Positive 1 plus negative 1 equals 0. So here's our second zero pair. And here's our third zero pair. Now I'm adding 3 zero pairs because I need 3 negatives in order to subtract them. So now that I have added my 3 zero pairs, you see that I also have added 1, 2, 3 negatives. So now I can actually subtract negative 3. So I'm going to black those out. Now that I've subtracted negative 3, how many counters do I have left? 1, 2, 3, 4, 5, 6, 7, 8, 9. And all the counters are yellow positive counters. So 6 minus negative 3 equals positive 9. Here we have negative 2 minus negative 5. So our first integer, or our first term, is a negative 2 integer. So we're going to represent that using 2 negative red chips. Here's 1 and 2. Then it wants us to subtract negative 5. But we only have 2 negative chips to subtract. So since we cannot take 5 away from 2, we'll need to add 3 zero pairs. Because if we add 3 zero pairs, we'll also be adding 3 more negatives. And that will give us our total of 5. So let's add our first zero pair. Let's add our second zero pair. And let's add our third zero pair. Now that we've added our 3 zero pairs, now you can see that we have 5 negative chips that we can now subtract. So now we can go ahead and subtract our negative 5. So I'm going to black out those chips. And what do I have left over? I have 1, 2, 3 yellow positive chips. So that means negative 2 minus negative 5 equals positive 3. So throughout all of the examples that we've done, here is what it looks like with just numbers. So rewriting a subtraction problem. To subtract an integer from another integer without using a number line or counters, you must add its opposite. So here we have 2 minus negative 6. If we're subtracting a negative integer, it's like adding its opposite. So we change our subtraction sign to addition. And what is the opposite of negative 6? Positive 6. So it's like adding positive 6. And we get our answer, positive 8. Let's see if that works again. Negative 2 minus negative 5. Again, subtracting a negative integer is like adding its opposite. So negative 2 plus, and what is the opposite of negative 5? Positive 5. So negative 2 plus 5 equals positive 3. 6 minus negative 3. Again, subtracting a negative integer is like adding its opposite. So 6 plus its opposite of negative 3, which is positive 3. So 6 plus 3 equals 9. Here we have negative 4 minus negative 3. Again, subtracting a negative integer is like adding its opposite. So negative 4 plus the opposite of negative 3, which is positive 3. So negative 4 plus 3 equals negative 1. Here are 4 practice problems I would like for you to complete. Please make sure this was a little bit of a difficult concept to get, so make sure you re-listen to the video a few times and also do the practice problems so when you have a question or you're unable to do the practice problems, I can at least see how much you did understand and what I still need to go over. So please make sure you do the practice problems as much as you can and go as far as you can so I can see what I need to help you with.